Welcome back to Vijay Academy. In this video, I will be explaining the question number 26 and 27 from Maths Standard Sample Paper. So question number 26 is like this. Given that root 3 is irrational, prove that 5 plus 2 root 3 is irrational. So here it's already given that root 3 is irrational. So we need to prove 5 plus 2 root 3 is irrational. If it is not mentioned that root 3 is irrational, we are supposed to prove that root 3 is irrational, and then we have to prove 5 plus 2 root 3 is irrational. So in this question, we have to prove 5 plus 2 root 3 is irrational directly. So now, to prove 5 plus 2 root 3 is irrational, let us use the method of contradiction, where we take 5 plus 2 root 3 as a rational number, and then we find that the assumption is wrong, and then we write the contradiction of that is 5 plus 2 root 3 is irrational. So let us do that now. Assume 5 plus 2 root 3 is a rational number. So as we know that every rational number can be written in the form of p by q, where p and q are co-primes and q is not equal to 0. Now let us write this as p by q. So 5 plus 2 root 3 equals to p by q. Now let us try to isolate root 3 in the LHS and transpose the other numbers to the RHS. So first let us transpose 5 to RHS. We get 2 root 3 equals to p by q minus 5, and simplify the RHS. So to simplify the RHS, we have to take the LCM of q and 1, which is q itself. So write the LCM as the common denominator and rewrite the numerators. Now the first numerator will be same because the first denominator and the common denominator are same. Now coming to the second denominator is 1. So we multiply this by q to get the common denominator q. So multiply the numerator also by q. So we get minus 5q. So 2 root 3 equals to p minus 5q divided by q. And transpose 2 also to isolate root 3. So finally we get root 3 equals to p minus 5q divided by 2q. So 2 is in multiplication. When it goes to, means when it is transposed to RHS, it goes to denominator. Now we got an equation that root 3 equals to p minus 5q divided by 2q. Look at the RHS. In RHS we have p, q, 5 and 2, which are integers. So RHS will be a rational number, but root 3 is an irrational number. This is not possible. So we can write that p minus 5q by 2q is a rational number, but root 3 is an irrational number. Therefore the assumption is wrong. Therefore the assumption is wrong. Since the assumption is wrong, then we can write it as 5 plus 2 root 3 is irrational. Therefore 5 plus 2 root 3 is an irrational number. Now let us move on to question number 26. So question number 27. So question number 27 is, if the zeros of the polynomial x square plus px plus q are double in value to the zeros of the polynomial 2x square minus 5x minus 3, Then find the values of P and Q. So it's given that the zeros of the first polynomial double in value to the zeros of the second polynomial. So if you take the zeros of second polynomial as alpha and beta, the zeros of the first polynomial will be 2 alpha and 2 beta. So now let us first write that sum of the zeros and product of the zeros of the second polynomial. So alpha and beta are the zeros of a polynomial 2x square minus 5x minus 3. So from this let us write the sum of the zeros, which is alpha plus beta equals to minus b by a. So let us substitute the value of b and a. So we get alpha plus beta equals to minus of minus 5, because the value of b is minus 5 and the value of a is 2. So we get minus of minus 5 by 2. So finally we get alpha plus beta equals to 5 by 2. And now let us write the product of the zeros, that is alpha into beta equals to c by a, and substitute the values of c and a. C is minus 3 and a is 2. So we got the sum of the zeros and the product of the zeros of the equation of the second equation. Now let us go to the sum of the zeros and the product of the zeros of the first equation. So as it is given, the zeros of the first equation are double in value to the zeros of the second equation. So let us write, let the zeros of x square plus px plus q be 2 alpha and 2 beta. 2 alpha and 2 beta. 2 alpha and 2 beta. Now let us take the sum of the zeros of the first polynomial. So that will be 2 alpha plus 2 beta is equal to b by a, where b is p. So minus b by a. It is minus b by a. So we can write this as minus p by a value is 1. So we can write minus p by 1. Now take 2 as common here from LHS. Taking 2 as common in the LHS, we can write this as 2 times alpha plus beta equals to minus p by 1. And substitute the value of alpha plus beta from the second equation. In the second polynomial, we get 2 times 5 by 2 equals to minus p. So where 2 and 2 gets cancelled, and then we can write that 5 is equal to minus p. So we can write p is equal to minus 5. And now let us write the product of the zeros. So we know that the product of the zeros is c by a. So the zeros are 2 alpha into 2 beta is equal to c by a, where c is q and a is 1. So let us write this directly as q by 1. Now let me multiply this 2 and 2. 2 into 2 is 4, and alpha into beta, let us replace alpha into beta by minus 3 by 2 that we are getting from the first equation, sorry, second equation. So replace alpha into beta by minus 3 by 2, which is equal to q. And simplifying this, we get 2 1s are 2 and 2 2s are 4. So finally we can write q equals to 2 into minus 3, that is minus 6. Thank you, children.